Hello and welcome to Algebra 1, Chapter 8.6, and today we're going to discuss perfect squares and factoring. And so this is our last kind of special pattern when we are factoring that we're going to talk about now. So let's step back a minute and talk about just, multiplying, or what does it mean to have x plus 3 squared? And so in Chapter 7 we did have a pattern for if you have a sum or a difference and you squared it, and I believe we got a squared plus 2ab plus b squared. And so I can look at this problem two different ways. I can put it straight into my pattern and I could say, okay, well this is a and this is b, and so if I want a squared, that's going to be x squared plus 2ab is I'm going to take a times b, which is going to be 3x, times 2 and get 6x, plus b squared, which is going to be 3 squared, which is 9. So I can do it that way. Or remember that to square something means to multiply it times itself. So I can do this, and I can FOIL by doing first, outside, inside, last, and combining like terms. Okay, so either way I get the same answer. And so what you'll see here on our next step then is what we're doing this chapter is if I want to factor this. So this is going to then factor into what we started up here with. And so this you can factor just like how we started factoring trinomials. We're going to put x and x, and we're going to look at it and go, okay, well, factors of 9 that add to be 6, it's going to be 3 and 3, and they're both going to be positive. And so I get that, which could also be written like that if I wanted to. Okay? And so this is going to be something that you could factor without noticing that these are going to be called perfect square trinomials. But if you do notice, it might be easier to help you factor them. So how do I tell if something is a perfect square trinomial? So this is really important. So this 4x squared plus 20x plus 25 is a perfect square trinomial. And so the first thing, so over here we got number 1, is the first term a perfect square? So is this something squared? It's 2x that's being squared. Okay, so that's important. And then you're going to look at your last term, because we're going to come over here now to number 2. Is the last term a perfect square? So what is this squared? Well, this is 5 that's being squared. And then last, we look in the very middle. So we're going to look at the middle last. Is the middle term twice the product of the square roots of the first and last term? So here's the square root of the first term. Here's the square root of the last term. If I multiply those together, I get 10x. If I double that, so times 2, is that the middle number? If the answer is yes, then this is a perfect square. So the next thing then would be, how do I factor a perfect square? So if you find that you have a perfect square, the symbols part here, so if I have this perfect square, so that was the first term is something squared, the last term is something squared, the middle term is twice the product of the square roots of the first and the last term, it factors into a plus b squared, the quantity a plus b squared. Okay. Now the only difference on the second one over here would be if I have a minus sign there, then there's going to be a minus sign there. Notice this one is always going to be positive because that term is squared, and anytime you square any number you end up with a positive. So the directions here, first of all, determine if it's a perfect square trinomial, and then if it is, we want to factor it. So you're going to walk through those steps that we just went through. Is the first term something squared? Yes, it is 5x that's being squared. So that would be the square root of the first term. Is the second term, the last term, is the last term something squared? Yes, it is 3. Okay, so they both have to be something squared. If you multiply those together, you get 15x. Okay? If I take that times 2, do I get that number? Yes, and it doesn't matter on the sign, but 15x times 2 would be 30x. So yes, this is a perfect square trinomial. It's the one that has the minus sign in it, so it's going to be a minus b squared, and so it factors into 5x minus 3 squared. So when you do your square roots to begin with, you are finding your a and your b. That's my a, that's my b. Okay, so there's the first one. Alright, so the second one, is this something squared? It is 7y, alright. Is this something squared? It is 6. And then you're going to multiply them together, and so you get 42y, and then you have to times it by 2. So if you times it by 2, do you get that? No, you'd get 84, so no, that's not a perfect square. Alright, so one more here. Is this something squared? It's an n. Is this something squared? It's a 12. Multiply them together, you get 12n. If I take that and double it, so times 2, do I get that number? I do, it's 24. And this is another one with a minus sign, so this becomes n minus 12 squared. Alright, so I think it's really important once you've learned lots of techniques, in this case of factoring, to really put them all in one place. And so this is a chart that discusses all the ways that we have factored. Remember that you always, always, always look for greatest common factor first. It doesn't matter how many terms it has. We discussed if you have 2 terms, you're going to look for a difference of squares. Okay, that was in 8.5. So 3 terms, you know, we definitely started out by just, well, this first of all, that was 8.3 and 8.4. We just factored it into 2 binomials. So here's my 2 binomials there. What might be helpful, though, is if you actually look for a perfect square trinomial first, that might help. You don't have to, but there's 3 options for if you have 3 terms. Anytime you have 4 or more terms, you have to factor by grouping. Okay, and do remember we talked about the AC method. This right here is the AC method that uses grouping for if you're factoring trinomials. So you probably should have all that written down in one place, and that would be beneficial for when you go to find it. So where we are now is, can I give you anything and you factor it? So instead of saying this is the section on perfect square trinomials, or this is the section on difference of squares, can you figure out how to factor something? Okay, and so looking here at these 3 examples, first of all, what should you always look for first? Always, 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 you look for a greatest common factor. So starting here at 6x squared minus 96, does it have a greatest common factor? It does, it's 6. So you're going to pull a 6 out front and get x squared minus 16. Okay, and then you might be done, but you might not be done. You have to look and ask yourself, does what's left factor again? Okay, and if I'm looking at x squared minus 16, do you know what that is? That's a difference of squares, because this is x that's being squared, this is 4 that's being squared. So we have to leave our 6 out front, and then a difference of squares factors into x plus 4 times x minus 4. So that would be our answer. And remember, just like all along, you can multiply that out, you will get back to where you began. So our second one's here, okay, 16y squared plus 8y minus 15. Is there a greatest common factor? There is not, okay. So it's a trinomial. So what we just learned today was we might check to see if it's a perfect square trinomial. Because this is 4y that's being squared. But is this a perfect square? Nope. Alright, so it's not a perfect square trinomial. So you need to try to factor it into 2 binomials. If we are going to use your AC method, which I would maybe suggest here, we're going to have to multiply 16 times negative 15, which is going to be negative 240. And then I need factors in negative 240 that happen to make positive 8. So, you could do a 24 and a 10. That wouldn't give you 8, so let's see here. Hopefully you're trying to figure these out. So I happen to do 12 and 20. I think I can get 8 out of 12 and 20. Especially since this is a negative, one of mine's going to have to be negative. If I want a positive 8, that 12 is going to have to be negative. So this becomes 16y squared minus 12y plus 20y minus 15. And then I'm factoring by grouping. Alright, so out of the first two terms, it looks like I have a 4y in common. So we're going to have then 4y minus 3. Make sure you get back where you came from. And the second two, if I pull out a 5, I would also have a 4y minus 3. Watch your signs there. So then if we pull 4y minus 3 out front, we're left with 4y plus 5. Okay, I'm looking at this last one here. One more time, what do? Always look for first. Greatest common factor has a greatest common factor of 2, which is going to leave me with x squared minus 16, which we happen to have already had on this page. So the 2 stays out front. X squared minus 16 is a difference of squares, so you get x plus 4, x minus 4. Sorry, my 4 didn't finish there. There we go. Alright, so I want to walk through some more one more time here. So first, you always look for a greatest common factor, and our first one here does not have one. And it's not a perfect square trinomial, and I know that because 20 is not a perfect square. So I don't have a perfect square trinomial. So I'm going to do my AC method. So my 9 times negative 20 is going to be negative 180. And so I need factors of negative 180 that I can make 3 out of. And we could look at 18 and 10, but I'm not going to make 3 out of that. Ah, 12 and 15. All right. And if I want, they have to have different signs, and I want a negative 3, so we're looking at a negative 15. So if we did 9t squared plus 12t minus 15t minus 20. Greatest common factor of the first two is 3t times 3t plus 4. Greatest common factor of the second two is going to be a negative 5, and I want to pull out the negative 5, so I get a positive 3t and a positive 4, and then I get 3t plus 4 times 3t minus 5. Alrighty. Next one here, 98x squared minus 200y squared. So I'll tell you that the x squared and the y squared kind of lead you to think, hey, this could be a difference of squares. The deal, though, is that 98 and 200 are not something squared. So, can I find a number that goes into both, is the first question. So let's start by taking out 2. They're both an even number. If I take out a 2, I'm going to left with 49x squared minus 100y squared. Alright, so now do I have a difference of squares? I do. This is 7x that's being squared. This is 10y that's being squared. So this factors, then, got to leave the 2 out front. It's going to be 7x plus 10y times 7x minus 10y. Alright, and our last one here, I would always suggest that you rearrange it. You really don't want to factor in a ascending order, so let's make it r squared minus 26r plus 169. Okay. Let's see if it's a perfect square trinomial, because this is r that's being squared. This happens to be 13 that's being squared. If I multiply those together, I get 13r. If I take that times 2, do I get that? Okay, look at that. Perfect square trinomial, r minus 13 squared. Alright, so the next thing we need to look at again is solving. And we want to factor this, okay? And so, being that this is a 4 and an 81, let's see if this is a perfect square trinomial. Because this is 2x that's being squared. This is 9 that's being squared. If I multiply those together, I get 18x. If I take that times 2, do I get 36? I do. Okay, so this factors into 2x plus 9 squared equals 0. Alright, so here's a new property that we're going to talk about, and it's called the square root property. If I have a square, how do I get rid of the square? I square root it. So this is actually going to leave me with 2x plus 9 equals 0. And the reason is because a square root, so here's my square root, and a square cancel. Okay, so if you had like the square root of 2 squared, that'd be the same thing as the square root of 4, which is the same thing as 2. So in the end, that square root and that square cancel and you get that number. So same thing happens here, square root and square cancel. We get 2x plus 9, and then all I need to do is solve that for x. There we go. Now, if you had not written it like that, if you had just factored it and you had gotten 2x plus 9 times 2x plus 9, and you had set them both equal to 0, guess what you would have still gotten? Negative 9 halves. You just would have gotten it twice. Alright, so again, we're going to factor because we're still really using the zero product property. So we want to factor this. This is a that's being squared, and I'm going to check again because that was a perfect square on that side. If I multiply those together, I get 6a. If I take that times 2, I get 12a. So this nicely factors into a plus 6 squared. How do I get rid of the squared? I'm going to square root it. You get a plus 6 equals 0. Just subtract the 6. A equals negative 6. And you could check these. I'm not checking them, but you could check them, make sure you have the right answers. So this is called the square root property. That if I have x squared equals n, so we've been having a binomial squared equals 0, actually is what we've been having. You're going to square root both sides. Now, the thing is that the n does not have to be equal to 0. If it's non-zero, you have to add a plus or minus there. So remember, these are quadratics. Quadratics have 2 answers. And so you add your plus or minus in front after you square root it to get your 2 answers. So let me show you what we're talking about. Alright, so this has actually already been factored for us. You don't need to unfactor or anything like, you don't need a FOIL or whatever. But it's not equal to 0, and that's okay. Using your square root property and not necessarily your zero product property, I can come in here and I can square root both sides. That's going to give me b minus 7, and then my property just said I need to add a plus or minus in front of this number, and that's going to be 6. So how you finish this is we're going to add 7, and you're going to write it b equals 7 plus or minus 6. And then you can actually do this, so you're going to do both of these cases. You're going to do 7 plus 6 and get 13, and you're going to do 7 minus 6 and get 1. And there's my 2 answers. Now you do need to check them, and we need to check both of them. So if we check 13 first, so 13 minus 7 is 6, and then 6 squared is 36. Remember, you work straight down and show all your steps. And then if I check 1 minus 7 is negative 6, and this is where you really have to keep that in parentheses there. Negative 6 squared is 36. Alright, we will do the problems we didn't do in class together and definitely do some more of these solving equations together. But make sure that you can look at a problem and know how to factor it, figure out how to factor it, and that you understand your zero product property that we've been using and now your square root property. Let me know if you have any questions, and have a great day.